Unit 3, Chapter 6, Fuel Cells. In this session, we hope to address these two study design points. We won't be able to do it comprehensively, but we'll provide you with some information that will help you to address these kind of questions, including energy efficiencies when you compare fuel cells with combustion reactions, or when you compare fuel cells and galvanic cells. And in terms of safety and fuel supply, that includes the storage of hydrogen, as well as the production of greenhouse gases in this entire process. So there will be few considerations on fuel cells coming up. As a Year 12 student, the worst you can do here is to copy it down to your notebook. You have access to this PowerPoint. It is time-consuming and it does not help much. What I would recommend you to do is to find multiple fuel cell exam-style questions after you have watched this session, and practice addressing those short answer questions so as to learn how to use the argument presented below to give a comprehensive analysis. Alright, let's start. So first consideration, hydrogen storage. Hydrogen is a gas at normal temperatures and as well as pressures. Okay, compared to normal fuels, which are liquids, this makes it really hard to store because you kind of need a huge container. At the same time, it has a really low boiling point. It means first of all, it requires a lot of energy to turn it into liquid if you want to store it as a liquid. Also, when it turns into a liquid for storage, then it requires good insulation to keep the tank cold. Insulation that good that can keep the container below -252 often requires energy supply to do so. Okay, so at the same time, you can expect some gas law equation kind of questions slipped in here. They might ask you, okay, for example, if 30 moles of hydrogen is needed to keep the fuel cell running for 3 hours, then what would be the pressure required to store this hydrogen at 20 degrees, given that the container has a capacity of 100 liter? Think about how you will address this question. The second consideration, safety with the storage of hydrogen. Hydrogen is an explosive gas. It ignites very readily, and therefore it brings in the danger of explosions. And also, if it leaks, it might cause suffocation. So it is not good to use in a closed environment. So it doesn't kill you right away, but gradually it might suffocate you. Okay. However, there is also a positive side to this consideration, that is, due to the low density of hydrogen gas, if it leaks into the air, it will disperse quickly into the atmosphere. Okay, so you just need to open the window if that's the case. Environmental impacts regarding the source of hydrogen as a fuel. Okay, so first of all, if we are using a hydrogen fuel cell, then water and heat are the only byproducts, which makes this kind of source of energy really, really clean. We can use the heat, we can pass on the heat to do something else, and also we can utilize the water straight away. Yeah. However, the best side of that is to produce hydrogen. So where do we get hydrogen? It cannot really be mined. Okay. Normally, industrial-wise, we are using a process called steam reformation, which the source of which is actually fossil fuels. Okay, so for example, as a methane, the reaction is written here. We're using methane to react with water at high temperature using nickel as a catalyst to produce hydrogen, and the carbon monoxide thus produced can again react with water to produce some more hydrogen using copper or iron as catalyst. Then some people would doubt or would actually, protest against this. They would say, Well, if you actually have methane, why don't you just use methane through combustion reaction and obtain the same energy? Okay, so that's a bad side of it. So the 2018 Northern Hemisphere examination, section B, question 7, actually refers to these pros and cons. Okay. It's worth have a look. And then environmental impacts of hydrogen fuels in terms of efficiency. So fuel cells has a one-step process, turning chemical energy into electrical energy. It reaches an efficiency of 40 to 60%, which is highly efficient. I think, vaguely remember, internal combustion engines' efficiency is somewhere around 30 to 40% in terms of conversion. Okay? However, as hydrogen is produced, so when we produce hydrogen, we actually lost a lot of waste heat in the reformation process. So to produce the hydrogen, we have to waste a lot of things, and then it can help us save energy. Okay, so is this really good? So what about all other fuel cells? Well, they are all highly efficient in energy conversion. Okay, as long as it's fuel cells, it's considered as efficient in converting energy. Okay, and all of them can have a constant supply of electricity. So they will generate electricity as long as fuel is supplied. Unlike your galvanic cell or a normal secondary cells, which requires recharging. And a lot of times when you're recharging it, you can't really use the energy from it, right? Okay. And third, it's quiet, especially compared to combustion reactions, which is used in traditional internal combustion engines. So you can see that one of the common advantages or promotions for hybrid cars, if they actually do use battery, those batteries are quiet. So that is a selling point as compared to conventional cars. Okay. We can use variety of fuels. We don't have to head on to one tree. Okay, and then it's suitable for scaled up production of energy on site. For example, it can be used for backup generator in hospitals. Okay, your textbook gives you more advantages. I've listed some of the common ones. And common disadvantages. The technology is still expensive, so the cheaper version of that would be just use internal combustion engines. Okay, and also it requires constant fuel supply, which is troublesome in closed systems. So 2018 VCAR exam has an actually design of linking fuel cells to solar panel that can produce hydrogen at the same time as you use it. Okay, so that design is worth looking at. It actually targets this disadvantage, constant fuel supply. Also, in terms of hydrogen fuel cells, if we want to use it for transport, then it is limited by lack of facilities for hydrogen storage and distribution. So you have petrol stations for petrols in your car. Do you have hydrogen stations to do so? Yeah. Also, the electrodes in fuel cells, as we said in the design, they are porous electrodes that normally comes with catalysts. They're expensive and short-lived, which means that we have to change it up very often. Okay. So again, there are more disadvantages in textbook, which is worth check it out.